Welcome, Algebra 2 students, to your lesson for today, and it's going to be your first part of lesson 7.5, which is going to be adding and subtracting radicals. So, our learning target for today is we are just going to be able to add and subtract radical expressions. So before we get started, there are two rules that we need to remember. In order to add and subtract radicals, the radicals must be like terms. So what I mean by that is the index, or the power, and the radicand, what's underneath the radical, must be the same. And we are going to see examples of this in the next slide. So if we take a look, remember the index and the radicand have to be the same. So if we look at these first example of like terms, they both have an index of 2 because it's unwritten there, and they both have radicands of 3b. So that means they're like terms, and this gives us the go-ahead that we can add or subtract. If we look at an example of unlike terms, notice this has an index of 3. This has that unwritten index of 2. So they are unlike because they don't have the same index. And if I look at my next example, they both have indexes of unwritten 2, so that's good. But however, this one has a radicand of 2b, this one has a radicand of 3b, so they're not alike, so therefore they're not like terms. So in order to add or subtract, we have to have like terms. And now we're going to see how to exactly add and subtract radicals. So let's look at my first example. I have 6 square root of 5 minus 2 square root of 5 plus just the square root of 5. I'm going to erase this. So it's just plus the square root of 5. However, I can put a 1 there because the square root of 5 is the same as just 1 square root of 5. So the first thing we need to check, do we have the same indexes? And we do, because unwritten 2 here, unwritten 2 here, unwritten 2 here, so that's good. Then we need to see, are my radicands the same? And they are. So that means they are like terms, so I can add or subtract. So when we're adding and subtracting radicals, all we're doing is we are going to add or subtract these numbers that are on the outside, and then the number that is on the inside, the radicand, and the index are going to stay the same. So those numbers on the outside, which was 6 minus 2 plus 1, we are going to combine those, and 6 minus 2 plus 1 would give us 5. So we get 5 from here, and that's just going to be square root of 5 would be our final answer, because your index and radicand are all going to stay the same, and they were all square root of 5. Can't simplify any farther, so there's our final answer. So let's take a look at the next example. Let's check our indexes. Unwritten 2, so we're good. However, our radicands are not the same, so right now they are not like terms, so we cannot add them. However, we need to see if we can reduce. So the 4 is going to stay the same. Oopsie. Don't do that. Get my marker. 4 is going to stay the same. I'm going to break up the square root of 8 to the square root of 4 times the square root of 2. And then I'm going to have plus. This 3 is going to bring down, this stay the same, and I can break up the square root of 50 to the square root of 25 and the square root of 2. Again, I'm always trying to break it up, so I'm looking for perfect squares. So 4 stays the same here. The square root of 4 gives me 2, and I just have the square root of 2 left. That'd be plus 3 here. Square root of 25 becomes 5, and now I have the square root of 2. Well, 4 times 2 is going to give me 8. Square root of 2 plus 3 times 5 is going to give me 15 square root of 2. Well, now if I look at it, indexes are the same, radicands are the same, so I can add 8 and 15, which would give me 23, and then I would still have the square root of 2 because the index and radicand stay the same. So my final answer would be 23 square root of 2. All right, 2 more examples to look at for today, and that is it. So let's look at example 3. So let's go ahead and check our indexes. 102, 102, 102. That's good. Let's check our radicans. 45, 80, 20, not the same. So we can't add them right now, but we need to see, can we reduce? 3 stays the same. Square root of 45, because we want to find perfect squares, we're going to break that into the square root of 9 times the square root of 5. Minus 5 stays the same. Square root of 80, perfect square that goes into that would be 16 times 5. Then we'd have plus, 4 stays the same. And the square root of 20, perfect square that goes into that is the square root of 4. And we'd use 5 because 4 times 5 gives us 20. So now we need to see, can I reduce? 3 times square root of 9 becomes 3. I still have the square root of 5, or the square root of 5 minus 5. Square root of 16 times 4, square root of 5, that would be plus 4 times square root of 4 becomes 2, square root of 5. Continuing further, 3 times 3 gives us 9, square root of 5, minus 5 times 4 gives us 20, square root of 5, plus 4 times 2 gives me 8, square root of 5. Well, now, because I've reduced as far as I can go, index radicand, indexes are all the same. My radicans are all now the same as the square root of 5. So I look at my outside numbers, and I am going to add or subtract. So I have 9 minus 20 and a plus 8. And 9 minus 20 plus 8 would give me a negative 3. And because they all are the square root of 5, that would be my final thing right. So my final answer would be negative 3 square root of 5. And I am done. All right, last example for today. So let's start by looking at our indexes. Well, I have a 3, I have a 5, I have a 5, and I have a 3, so they're not all the same. And if I notice, the 5s have different radicans and the 3 have different radicans. So right now, I don't have any like terms, so I can't do any adding or subtracting. So before we start, we're going to find some common cubed roots and some common fifth roots. So if I take 2 to the 3rd, that is going to give me 8. 2 to the 4th would be 2 times 2 times 2 times 2. Actually, hold on. Do not want to do that. I'm looking for cubed powers. So I'd have 3 to the 3rd. So 3 times 3 times 3 would give me 27. 4 to the 3rd, 4 times 4 times 4 would give me 64. And we're going to go up till 5 to the 3rd. Grab that. 5 to the power of 3. So 5 times 5 times 5 would give me 125. So that's going to help us break down our cube roots. So my negative 2 is going to stay the same. And if I look, if I take 108 and divide it by 8, that doesn't come out evenly. However, if I take 27 divided by 8, that would come out evenly. It would be 27 times 4. So I would have the cubed root of 27, and this would break into the cubed root of 4. Now I'm going to look at this one. So I have my plus 8. So I'm going to see what cubed root would go in the 320, and that would be 64. So I could break this up into the cubed root of 64, and this would be the cubed root of 5, because 64 times 5 gives me 320. So that helps me with my cubed roots. So let's take a look at my fifth roots. So we're going to do that over here. So 2 to the 5th. So 2 to the 5th power is going to be 32. 3 to the 5th, if I take 3 to the power of 5, that would give me 243. I take 4 to the power of 5. So 4 to the 5th, that would give me 1,024. I don't need to go any higher than that because my numbers are getting outrageously big. So let's see what we have here with this 192. which one of these would go evenly into 192? And your answer would be 32. So I'm going to break up this into the fifth root of 32 and the fifth root of 6, because 32 times 6 would give me 192. And then if I look at my next one, I'd minus 7. We're trying to see which of these numbers goes in the 486 nice and evenly, and that would be 243. So I can break that up into the fifth root of 243 and then into the fifth root of 2, because 243 times 2 gives me 486. So again, I use my powers in order to figure out these numbers that are going to reduce based on your cubed root and your fifth root. So let's reduce even farther. So I have negative 2. If I take the cubed root of 27, because that is going to give me 3, and the cubed root of 4 is going to stay the same. Okay? Plus, if I take the fifth root of 32, that is going to give me 2, and then I would have the fifth root of 6 still left over. Then I would have minus 7. If I look at the fifth root of 243, because 3 to the fifth is 243, so the fifth root of 243 would be 3, and I would still have the fifth root of 2, and that would be plus 8. I looked at the cubed root of 64. Well, 4 to the third is 64, so that means the cubed root of 64 would simply be 4, and that would be times the third root of 5. So let's try to simplify a little bit farther. If I multiply 2 times 3, that would give me negative 6, and I would have the cubed root of 4 plus, 2 it doesn't have anything to be multiplied by, so that would be 2 times the fifth root of 6 minus 7 times 3, which would be 21, times the fifth root of 2. And this would be plus 8 times 4, which would be 32, times the cubed root of 5. Well, now if I look, I have an index of 3 and an index of 3, but my radicans are different, so I still can't add those together. Index of 5, radicans are different, so I can't even add those together. So the last thing I'm going to do is I'm going to rewrite this, putting these radicans next to each other. So I'm going to have negative 6 times the cubed root of 4 plus 32 times the cubed root of 5 plus 2 times the fifth root of, erase that, make that a little bit better. So 2 times the fifth root of 6, and that would be minus 21 times the fifth root of 2. So there you go. Again, we can't simplify any farther, because if I look, index of 3, but radicans are different. Index of 5, radicans are different, so that is my final answer. So your guys' assignment for today is to do worksheet 7.5, the adding, subtracting, multiplying radicals worksheet that you're going to pick up today, and we're just doing the front page 1 through 12 only. All right, thanks, and have a great day.